past decade. So
as I think about my time at Google, right below us in the garage, Urs and his team were building these super secret shipping container data centers. They had these like data center in a box that you could ship anywhere as long as you had access to water and power, it could connect to the internet, and you could scale data center capacity all over the world. That was 20 years ago. It's always seemed to me that one of Google's core and not well understood advantages was its infrastructure advantage, something that Google's invested in to its core from the beginning. Can you tell me a little bit about where you view Google's infrastructure advantage playing out in the AI competitive landscape today? How does it translate into cost, speed, product quality, and where do you guys think about investing the $70 billion of CapEx this year in the chip layer, in the networking, the data center?
We can unpack both, right? Like where our CapEx is going. But on your first part, right, like one of the ways, we look at the Pareto frontier of performance and cost. Google literally is on the Pareto frontier. So we deliver the best models at the most cost-effective price point, right? And our Flash series of models are a real workhorse in the industry, right? And part of why we are able to do that is because we train and serve our models on our infrastructure, including TPUs, right? And we are in our 7th generation of TPUs, and we built our first version in 2017. I remember talking about it at Google I/O. Probably people didn't pay attention to it because, why are you building a specific machine learning accelerator chip? Look, it plays out everywhere. To your earlier question on cost per query in search, the reason we feel comfortable we can serve it at that scale is because we are constantly innovating through each generation, including chips which are really, really good at inference, right? And Ironwood, which is our latest in our TPU series, a single part of Ironwood is over 40 exaflops, right? And so the scale of these things are incredible, and we have thought about our info all the way from subsea cables to the scale at which we do infrastructure is unparalleled. And I've always viewed that full stack approach, deep infrastructure, foundational, fundamental R&D on top of it, and then you build and innovate on top of that. And I think that approach will serve us well over time. But it really, empirically plays out in, the cost at which we are able to provide our models. Part of the reason we've had a lot of traction with Gemini 2.5 series is not only are they great models, but we are offering it at a very attractive value. And we can do that because, we are driving our infrastructure costs down. On the $75 billion in CapEx for 2025, obviously majority of that goes into servers, data centers, and so on, servers being the vast portion of it. I would say on looking at 2025 and looking at the compute part of the spend, half of that is going towards our cloud business in 2025. And obviously that is a very different, it's a very different business to search and so on. So a lot of it is to power the innovations from Google DeepMind and pushing the frontier. And we're doing it across many dimensions, right? Not just large language models, but even there, doing it across not just text, images, video, et cetera, building world models, right? So there's just a lot of innovation which we are pushing on the frontier, obviously to support our core products like Search, YouTube, Gemini, et cetera. But 50% of the compute goes towards Google Cloud.
Let's just talk about chips for a second. This is a big part of the conversation is NVIDIA's got the real market monopoly in AI is what everyone says. Do TPUs provide a wholesale replacement for your need for NVIDIA in the supply chain, or is NVIDIA still a core part of the mix in the data center for training versus inference in LLMs versus other models? Maybe just share your understanding of where the mix evolves to for you guys.
Look, first of all, at a high level, NVIDIA is a phenomenal company. Jensen is awesome. We have been working with NVIDIA now for a very, very long time, and we continue to do so, right? And we serve a lot of the Gemini traffic on GPUs as well, right? And so we give customers choice, et cetera. internally, we train our Gemini models on TPUs, right? And we serve it that way across our products. But we use both. And I do think, I do think everyone in the industry is going to try and do something like that. But it's NVIDIA's R&D and their ability to drive that innovation. Their software stack is world class. So, they have a lot of advantages as a company, and I have extraordinary respect for them. But we've always had, we are committed. We are actually deploying GPUs internally as well. I think I like that flexibility, but we are also long-term committed to the TPU direction as well. So I think it's a good combination to have both, and I think we push each other, and drive the frontier forward.
Just going back, so there's an infrastructure advantage inherent in all of the investment that's been made for 20 plus years and the continued investment. A lot of folks have said that some of the performance in foundational LLMs is kind of starting to plateau. And as a result, we're seeing a less kind of differentiated landscape amongst the competitors. And that's should be a consideration for Google. That's the outside kind of narrative. Can you share a little bit about, and then I want to come back to non-LLM models where there's other advantages for Google in a minute, but maybe just on this point, how much more of an opportunity to continue to evolve LLMs is there? Where does Google's advantage lie in maintaining better performance in the models over time?
I think maybe it was Andrej Karpathy who used the term AGI, which is like he called it artificial jagged intelligence, right? So I think the progress is not going to be always smooth, right? Like you go through these periods, it looks like something slow, and then you see a paradigm breakthrough, et cetera. And it's been going like that for a while. I think obviously over the last couple of years, all of us scaled up on pre-training, and then there was a lot of momentum with post-training, and then with inference compute, and now, there's progress with how do you take all that and stitch together in agentic workflows and so on. So I do think there's a lot of progress, and it feels pretty continuous to me, right? I think it's both true. Progress gets harder, which I think will distinguish the elite teams, at least on the foundational side. I think that might be a factor. I felt the harder the problem is, I think we are well set up for that. I think we are well set up for that. I do think we are pushing the research frontier in a much broader way than most other people, beyond just LLMs, transformer-based models. I mean, diffusion. Do you do diffusion-based models? All those areas we are exploring in a deep way, right? So, there's always the chance that we may reach a point where, you quite don't get that returns to the additional compute you're going to put in. But I quite haven't seen it yet, right? The progress looks maybe harder because you're now dealing with a lot more compute. So you're really running into the loss of can I actually get as many electricians as I can to build the data centers at the speed, all that stuff. But I haven't seen, or at least talking to our researchers, haven't seen anything fundamentally, we are not going to be able to move past it this point or something like that.
Does Google have a data advantage with YouTube or other products or services? Are you able to train on that data in a way that others can't?
I think we have the opportunity to create much better experiences for people. I think people use products like Gmail, Calendar, Docs, YouTube, Search, etc. So with their permission, taking that personal context into account, I think we can deliver much better experiences. We are working on that, but it's something on which we have to deliver. But I view that as one of the differentiated innovation opportunities we have ahead as a company, but it's something we are thoughtfully working on. We'll make progress there.
That makes a lot of sense. If search evolves, and I've been using a lot of voice AI tools, I find them incredible. I can have a conversation, access the news, dive deep on a topic. It's